During electronic manufacturing test, it's often necessary to ensure the integrity of the I/O components. But it's difficult to identify problems such as high leakage currents through output drivers or incorrect voltage clamp with a pure functional test alone. Therefore, parametric tests are commonly used to test some I/O components. The types of I/O components tested in manufacturing may include resistors, bypass capacitors, FET drivers, and high-voltage input-output clamps. We'll demonstrate measurements on many of these types of devices using an electronic functional test demo board and software. This is a view of the system we'll be using for this demonstration. It includes the Agilent M9183A DMM, Agilent M9186A VI source, and electronic functional test demo board. We'll start by making a basic 2-wire ohms measurement. We'll use the Agilent M9183A DMM to measure a precision 100 ohm resistor. Here's a diagram of the measurement with the demo device shown on the right. Notice our result shows a measurement of 101.37 ohms. It's not exactly 100 ohms due to the resistance of the test cabling. A 2-wire measurement cannot compensate for this wiring. We can improve our test result by using the 4-wire ohms function on the Agilent DMM, which again is shown on the right. After this measurement, we see a much more accurate result, showing a value of 99.99 ohms, which matches the 1% tolerance specification of the resistor. Another common measurement in manufacturing is capacitance. In this case, we're using the DMM to measure a 0.1 microfarad capacitor on the demo board. We can see a result from the Agilent DMM of 0.101 microfarads. We can use resistors on our test device to demonstrate another common measurement in manufacturing, where we'll source voltage and measure current. If a relatively low compliance voltage is needed, we can use the built-in voltage source of the DMM. Setting this source to 1 volt and measuring current, we see an expected result of 9.95 milliamps. In manufacturing, we may also need to source current and measure voltage. The Agilent M9186A isolated voltage current source is a good choice for these types of measurements. Here, we'll use it to source a current through 2 diodes. To ensure the diodes are functioning correctly, we'll measure the voltage drop across them with the DMM. Upon completing this measurement, we see the expected result of 2 volts. This is an indication that the diodes are indeed switched on. In some cases, a high compliance voltage on the source is required for certain measurements. We'll demonstrate the unique 100-volt compliance limit of the Agilent M9186A source by measuring the clamp voltage across a Zener diode. If we apply 20 milliamps to the diode with the source, we'll be able to measure the clamp voltage with the DMM. Here, our result is 20.169 volts. Finally, there are also cases in manufacturing where it's necessary to source a high voltage and measure a current. As an example, we'll use the Agilent M9186A VI source to supply a bias voltage to a MOSFET on the demo board and measure the resulting leakage current with the DMM. This type of measurement can be used to identify MOSFETs damaged due to electrostatic discharge, which will result in a higher than expected leakage current. Once again, we benefit from the high compliance limit of the source by applying 60 volts. After the measurement, we see a result of less than 1 nanoamp, which is well under the specifications of this particular MOSFET. Put Agilent's new PXI VI source and DMM solutions to work on your most challenging electronics manufacturing test applications. These solutions can be combined in various source measure applications to improve your measurement results by ensuring the integrity of I/O components.